Thank you, everybody. So I call that picture When I Had Hair. Does everyone know what those things are? Has everyone interacted with them? It's kind of a survey I've been doing for some time. And I go into an audience and I ask for people who don't know what it is or hasn't seen it. I don't see many hands. If I extrapolate that, try to pull some data out of that, that means that at this point on the planet, maybe half or more of the human beings have seen those, touched those, or at least have some knowledge of them. I invented that when I was an undergraduate at MIT. It was a way to show off to my then new girlfriend. I was competing with her other boyfriend who was trying to push out of the scene, who was a 12-string guitar player, but I had light to work with. Funny, the first interaction that people had with these outside of me in the lab was in a scenario where people were, this is the 70s now, right? Experimenting with various kinds of substances, and it took the stage all on its own. So I started thinking about this kind of thing as, a shared hallucination. And those of you that know William Gibson, that's one way to describe cyberspace, is a shared hallucination. Electronic drugs was another thing that I would tell people when we were trying to push these out in the marketplace. So anyway, started a career down the path of sharing information, and the Media Lab was my next stop. Actually, before that, the Architecture Machine Group, which became the Media Lab at MIT, run by Nick Negroponte. I'm going to talk today. Where's my clicker? Do I have a clicker? Ah, great. Thank you. I'm going to talk today about the interface between AI and AR. And what I really want to do is take a look at how those are influencing each other and in which direction that influence is going. We think about AI in our existence today and how we interact with AI, whether it's audio, visual, tactile, other ways. But if AR is going to be an interface, then in some ways we have to make the AI do part of that lifting and tailor those applications towards what augmented reality and extreme reality, extended reality, mixed reality, virtual reality, all of those realities, which we are now trying to distill down into existing systems. So my company, Creative Micro, is focused on doing customized reality or custom reality. And that really just pertains to the fact that every user of a reality system and its interface with artificial intelligence is perhaps looking for a different answer to the question of how does the technology help me live my life? How does it help me in my day-to-day goals? And how can this be, to use a Nick Negroponte term, how can it be idiosyncratic? So the ultimate goal, provide users with enhanced situation awareness, augmented cognition through contextual AI application. That's kind of a big mouthful, but that's what I'm going to be talking about here. So as a company, we're small. We have about 30 employees. That's growing as we get more involved in making larger production runs of custom systems. But what we do is make custom AR. If you have a use and none of the commercial systems do the job quite the way you want, we're the guys you go to make that need into a working system. We've primarily had government and military customers over the last 5 years. That's helped us get a really good foothold in that market, in the sort of rugged wearable systems that cover specific users' needs in a way that is defined largely by what the combination of technology and applications can do. These are some examples of a few of the systems we've done They all look pretty goofy. If you were trying to wear these on the street, people would probably wonder if you're trying to Borg them. But it is, it is a starting point for a lot of the technology. The technology of wearable displays started with head-up displays in aircraft, moving towards work that was done by NASA many years ago. I don't know if you followed what was going on in the early stage of virtual reality, not too far down the street at Ames with Scott Fisher, who was also at the Architecture Machine Group when I was there. These are not something you're going to see in the marketplace immediately, but the next stages of them certainly are getting adapted for the kind of everyday uses that you would probably see. So something like a dive goggle that's got a built-in display. Well, you'll see examples out there where people are wearing motorcycle helmets that have a micro display built in. That's letting people do the same thing underwater. A lot of our stuff had to do with night vision for the military, being able to overlay information, data of various kinds, imagery, symbology, mission important information on top of an image that is either thermal or light intensified through a night vision tube. All right, so where does the augmented artificial intelligence interface, AI squared, however you want to call it, a lot of different names for this. But you do have, as you know, real-time sensing in your environment. You're living in an Internet of Things. You are an Internet node, and you have a lot of things that you're in contact with that are constantly generating data about you, about your environment. So it's all right there, right? We just have to figure out how to collect it all and put it to use and bring it back to the user. So from the front end side, being able to assimilate a lot of very useful information, it's there. It's just a matter of, well, little things like bandwidth, small things like how do you process it, where are the algorithms, how are they controlled, how do you keep track of the information that's critical to you, and how do you make it work for you. So what does this really mean? If we're going to have contextual AI support, then we need to communicate effectively with it. It needs to give us information. We need to share information with it. And then you extend it into new use cases and new applications. Unfortunately, the generic hardware that's out there is really kind of looking through a soda straw at the problem. And our goal is to expand that soda straw into as many use cases as possible, recognizing the fact that it's a component world we live in. So by looking at the component process of building an AR system, we've been able to achieve really fairly economic constructs, things that don't take millions or billions of dollars to build, but they're built from essentially off-the-shelf technology with some magic that we throw in of things that aren't currently off-the-shelf, but will be probably before too long. So we cook this into a set of requirements based on the customer's visions and goals. We've gotten very adept, as I'm sure many of you have, at understanding what a user is really looking for. What is the experience? What is the cognitive support? What are the questions they're addressing? And from that, come up with an analysis that then helps us through the next step of the process, which is designing all the various elements, building that, doing refinement, and eventually the final deliverable product. So if we walk through that, these are all fairly obvious, but I think the piece that is really worth looking at is in the design integration. What I was saying about being able to capture the investment that has been there from billions of dollars that have gone in from many different directions into the technology base that we can draw from. We don't need to invent everything, is what we say in our facility. We like to invent when we need to, but we also like to take advantage of the fact that someone has already got sunk cost in their fabrication facilities, and they want to have a market, and we want to help them sell their stuff. So things like the displays and the optics. we build a lot of that in-house if the form factor of the commercial items doesn't fit. We can also buy off-the-shelf elements that we can plug together to make this work. Processors, as I'm sure you know, you're getting a lot of bang for your buck, a lot of bytes for the buck these days, and it just keeps getting better and better. Why should we go out and spend $1 billion on a fab or have a multi-million-dollar turn on a die that's going to do something that I can go to Intel and I can buy that? So that's essentially our approach, being a small shop, to be able to compete with stuff that is much bigger from bigger players. You're probably all familiar with IVAS, the system that Microsoft has picked up to produce for the Defense Department. Well, that's potentially a $2.5 billion sale for them. A lot of that is going to be software, a lot of that's going to be support service, but the initial purchase order of about $500 million was for hardware. I wish them luck, because what I've seen of their system today is going to be very hard-pressed. A lot of work to be done to get it to go into environments where you've got mud and dirt and explosions and bullets and people wanting to have this stuff work regardless. Because frankly, as you would, if a soldier is wearing a piece of kit, piece of hardware that does not work, they're not wearing it very long, because their life needs to depend on it or they're not going to wear it. So these are things that fall into this whole process of the customized delivery. So one of the systems that we've produced and are delivering and finding more traction is this idea of bringing AI to the battlefield, bringing it through the augmented reality displays. So information that, in this case, a tactical air controller, that's the guy that gets dropped out of the back of an airplane, probably about 40,000 feet above the battlefield, parachutes in, is going to dig himself into a hole, and looks out and sees where there needs to be close air support or targets that need to be taken out before the rest of the troops come in. So you see a lot of that stuff in movies. But for real, those guys do that. And what they need to be able to do is pay attention to the environment, because they could very likely be in a firefight while they're trying to do all that stuff. They could have a target that is in contact with them. And if that's what's happening, you haven't got time. The picture of the guy with his head down, you notice he's wearing a chest-mounted display. He's basically working with the technology that existed up to this point. So what we're doing is delivering a new generation of ways to get information in an environment that is, really quite dangerous, and while you're maintaining your situational awareness, trying to do a very hard job. Another area where we've been building systems and trying to get them into the user's hands is for first responders. This is a system for firefighters that enables them to both work in an environment where they have to be having a mask, they have a self-contained breathing apparatus that has a display with a thermal camera built in, so that they can go into a burning building. They can find that person that they can't see otherwise because of the smoke. They can see them lying on the floor. They can see that there's a hot door. Don't open that door. There's a hole in the floor. Don't fall in the hole. So all of those things are now realizable with this technology. In addition to that, we can take that system, give it simulation data, give it visualization of a scenario, and help then in the training and simulation process. And then the dive mask is another scenario, mission critical or life critical information, knowing how much air you have, knowing how deep you are, knowing how long you've been in the water, being able to communicate with the rest of people in your dive group, with your buddy. All of that is now feasible at depths. This system goes to 100 feet underwater. Being able to do that effectively in water obviously is valuable, because now you've got a self-contained system that is able to deal with everything you can deal with. It can give information about your status, hooking it up to the same kind of biometrics that are, everyone's wearing probably a watch that's got a biometric in it, being able to then get that information displayed where you can use it in your immediate environment. And then where do we go? Well, you know, I hope I'm not saying the obvious to everybody here, but yeah, why would we want to be wearing glasses if we didn't need to? Well, because if that's a display that's giving you information that is, in the previous cases, life or mission critical, can it also be looking at ways to deliver information to you that is just lifestyle critical? Stuff that in some instances may supersede any vanity that would go along with having the best looking glasses or not wearing glasses. I mean, maybe we're going to get to the point, I would predict that enough people are working on it, that we will eventually see contact lenses doing what wearable displays are. And then someday, maybe that's a direct neural connection. That's quite a ways away. But in the meantime, wearing something that has information that's connecting AI resources to give you a boost, to give you a cognitive enhancement, to augment your reality in a way that is done through data resources, through machine learning, through all of the depth of information that is out there and potentially accessible to you real time. Remember, you're a sensor as well, and everything you're wearing is sensing your environment, and all of the networks are providing you with the potential for a really substantial boost in your existence. I particularly like this idea because it is also something where, as people age, mental faculties deteriorate. There are undoubtedly in all of our futures some amount of need for cognitive support. I get excited to see that maybe we can be, as a group, building technology that helps us extend our functional existence into our later years without much in the way of deterioration. So a couple other use cases. We're not as smart as the machines. The machines become a mechanism for us to do the things we need to do that we don't otherwise know how to do. So I don't know how many people here can, see in multispectral regions that are outside of our visible, but if you can see in the infrared, if you can see in hyperspectral, if you have ability to access the database or SenseNet that is critical to your job, that's all good things. Likewise, helping us make better decisions in the way that we prosecute our efforts, being supported by AIs that do some thinking for us and make suggestions. What I like to think of as the situation where we're used to coming up with problems and asking computers to help us solve them because they can do processing faster than we can. As we approach true AIs, they will likely be able to find the problem, solve the problem, and then maybe tell us that they did. Maybe we don't care. Maybe that's not part of the mission. All right, so one of the big things that obviously needs to be considered here is how do you connect all this? The bandwidth tax, if you will, is extreme. Are we moving into a 5G world to enable all this? I would say most definitely, and I think our host on this session is putting a sharp point on that. So until we have the bandwidth, just think about how many gigabits per second of information it takes to feed all the pixels in a high resolution display. It's a huge number, and unless we have some way to process some of that information locally in what we're wearing, and be able to pipe in the necessary bandwidth to make all this work, it's going to be a hard task. So that's the other important missing piece. So let me leave this with essentially the thought that we need to see the convergence of AI into AR. and look at it from maybe that direction as much or more so than thinking about AR as just a mechanism to display what the AIs have to offer. So thank you very much. Any questions?